Well, today we're in Shafter. We're at Sequoia Elementary School, and today we're here to... Well, today we're at Sequoia Elementary School with 6th grader NEVEAH. You ready?
Yes.
All right. I have had this problem waiting for the perfect student, and you are that person. You ready?
Yes.
All right. Why don't you go ahead and read what we have to do?
Find the difference.
And what problem do we have to work on?
We have 7 3/4 minus 5 4/5.
All right. How would you like to start this?
Well, I would... Sometimes I would multiply 5 times 5 and 7 times 4. Or we could do 3/4 minus 4/5. So you can't do 3 minus 4. So you would...
Yeah, that's kind of hard to do all that, isn't it? So how about if we do this? So you were talking about multiplying them and then turning them into improper fractions. How about if we leave the whole numbers the same, and let's get a common denominator here first. All right?
So it would be 20
Okay.
for the common denominator.
All right, so why don't you go ahead and rewrite the problem. So we have 7 and something over 20 now, right?
Yes, we have 7 and 15 over 20.
All right, and for students that are just learning how to do this, how did you come up with 15 over 20?
Well, what I did was, since we have 4 times 5, we multiply 4 times 5 and you get 20. So whatever you do to the bottom, you must do to the top. So it'd be 3 times 5, which is 15.
Okay, because the common denominator for 4 and 5 is 20. And you just happen to hit the lowest one on that. All right?
So then you do minus 5. 5 times 4 and 4 times 4 is 5 and 16 over 20.
Okay.
Equals 15 minus 15 twentieths minus 16 twentieths is...
Can't do that, can we? So if we can't just go 15 minus 16, we're going to have to borrow from something, right?
Yes.
So what would you like to borrow from?
We would borrow from 7.
Perfect. And what will that now become?
7 would become 6, and 15 would become 16?
No, because you're borrowing a whole 1. Okay, and a whole 1 would be the same as 20 over 20, since that's the denominator we're working with. So if we're going to add 20 twentieths to this, how many twentieths will we now have?
$35 over
Perfect.
20?
Right, so we'll have 6 and 35 twentieths now. Make sense? Because if we're borrowing a whole 1, we're borrowing 20 twentieths. Because any number, top and bottom the same, is equal to 1, right? So now we have 6 and 35 twentieths minus 5 and 16 twentieths. Now can we go ahead and do that problem?
Yes.
Okay.
So I would just rewrite it to 6 and 35 over 20 minus 5 and 16 twentieths.
Okay.
And that equals 10 twentieths. But then
Almost. Because 35 minus 16. So if you want to work it out on the side over there, do 35 minus 16.
you 19.
There you go. So instead of the 10 twentieths, we're going to have...
19 twentieths.
Perfect. What else do we need to do?
So now you have to subtract 6 and 5. So 6 minus 5 is 1. 1 and 19 twentieths is your answer.
Perfect. Nicely done. I was almost going to think you were going to forget about that 6 and 5, but you got it. Perfect work.